The hackathon was amazing this year. We had a terrific high degree of creativity and enthusiasm from the next generation of global engineers. Our preliminary and final judges have been from all over the world, and the hackathon was a truly representative international engineering exercise. We want to thank everyone who participated, from the university students and the judges to the working groups and the partners. This has been a wonderful experience. And now let's hear a great message of support from our hackathon sponsor, Intel, and then we'll be joined by Gong Ke and Marlene Kanga to announce the World Engineering Day Hackathon winners.
On behalf of the sponsors of the 2022 World Engineering Day Hackathon, to the young engineers with us today, congratulations. For many of you, this has been a journey of months and even years of hard work. You experienced that engineering could be a driving force for changes and for good, a belief we wholeheartedly share with you. Although this hackathon is a memorable chapter in your life, it is what we are proud to support and be part of. Intel is a company with innovation in our DNA. In the Interlabs China, where I'm working, there are many engineers who solve the problem with technology every day. We are excited about the new possibilities that engineering is creating and how we see this potential from your projects. We are proud because we believe the future world will be powered by your passion, your creativity, and innovation. Your achievements in this year's World Engineering Day Hackathon are just the beginning of your wonderful work. Let's work together to build a better and a smarter future.
Hello everyone, I'm Kei Gong, the president of the World Federation of Engineering Organizations, WFEO, and I'm now in Costa Rica after a long flight from China. I trust you have enjoyed the 24 hours live broadcast and the celebration in your country. The theme of this year's World Engineering Day is Build Back Wiser, Engineering the Future. This year, we encourage more young engineering students and young engineers to join in the celebration by conceiving a World Engineering Hackathon. This hackathon is the world first event that has engaged hundreds of students, thousands of students from all over the world, from all continents of the world. This amazing international event would not have been possible without the support from our international partners, UNESCO and FIDIC, IFIS, GEDC, IEA, INVEST, and EWB. My sincere thanks to all of you. I also thank Intel because in this hackathon, we also have Intel Insight, whose generous contributions have enabled us to deliver these once-in-a-lifetime experiences to hundreds of young students and young engineers around the world. I would like to thank our volunteer group led by Dr. Marlene Kanga, the immediate past president of WFEO, and representatives from our Young Engineers Future Leader Committee and Engineers Without Border, SPEED, the student arm of IFIS and GEDC, and Young Engineers Australia. Finally, a special thanks to all judges that made this competition possible. Our preliminary judge panel comprises 40 judges who volunteered their time to assess all entries from all over the world. Our finalist judges consist of representatives of our international partners and UNESCO. This was truly a great effort of our inaugural international competition. Now, to announce the winners, I would like to introduce the WFU immediate past president, Dr. Marlin Kanga, leader of the hackathon working team. Marlin, the floor is over to you to the other end of the globe.
Thank you very much, President Gonke. It's a great pleasure to be here to announce the winner of the inaugural World Engineering Day Global Hackathon from Sydney, Australia, as you said, from the other side of the world. To briefly recap, the participants for the Global Hackathon were asked to choose from one of three challenges. Challenge 1, responsible and innovative use of materials and the reduction of non-biodegradable waste, such as plastics. Challenge 2, biomimicry in engineering solutions, learning from nature for sustainable solutions that result in innovation, optimal resource use, and healthy and improved living. Challenge 3 was water, accessibility in a changing climate, climate-resilient water management systems to ensure safe and ongoing access for all. Each of the challenges involved one or more of the UN Sustainable Development Goals. And most importantly, the judging criteria were based on the recently approved International Engineering Alliance graduate attributes and professional competencies. This enabled participating engineering students and young engineers to demonstrate their abilities to produce sustainable solutions and outcomes that align with these attributes. We received more than 120 wonderful entries in the first round from more than 20 countries around the world. There were nearly 500 individual members of these teams, and more than 90% of them were engineering students. I would like to thank each and every one of the participants in this global hackathon. Each and every one of you are winners for taking part, and I'm sure you've learned a great deal by applying what you've learned in your engineering courses to developing a real-world practical solution. Now, on offer, we have three great prizes. For first position, a prize of 4,000 euros. For second position, the team receives a prize of 2,000 euros. And in third place, a prize of 1,000 euros. All participants will receive a certificate of participation from the World Federation of Engineering Organizations. Our 40 preliminary judges from around the globe were able to review the entries and selected 9 finalists to enter the finalist round. These 9 finalists were announced on the 14th of February and were given 2 weeks to develop a video presentation of their solution. We've shown these 9 videos throughout the 24-hour live event, and I hope you enjoyed seeing them. The 9 finalists were, in no particular order, HIAPAC from Egerton University, Kenya, Africa; Indus from Odisha University of Technology and Research, Bhubaneswar, India; Hephaestus from Hyderabad Institute of Technology and Management, also from India; Ruby from Monash University, Australia; iCity, Harbin Engineering University, China; Mobile Rain Harvesting System from the University of British Columbia, Okanagan, Canada; Wonderfest from Batangas State University, the Philippines; 466 from Nankai University, China; and last but not least, GRADS from the University of British Columbia, Okanagan, Canada. Our judges have now completed the judging, and I'm pleased to announce the winners of the World Engineering Day 2022 Hackathon. In third place, the winner of the 1,000 euro prize is Team HIAPAC. This team is from Egerton University in Kenya, and its members are Charles Rugendu and Joseph Nuguthuru. Congratulations to Team HIAPAC. You addressed Challenge 1, responsible and innovative use of materials. The judges were very encouraging and said your entry was a standout. It was well presented, clever, and demonstrated great ingenuity. The judges saw your passion to make a difference and the further additional initiatives that you propose to plant trees, clean up rivers, and shows that you are committed individuals who are grappling with the complexity of the issue that you've taken on. We certainly hope that you will be successful with your venture. In second place, I'm pleased to announce the prize of 2,000 euros goes to Teen Mobile Rain Harvesting System from the University of British Columbia, Okanagan, Canada. Congratulations to Amar Zavahir, Patrick Julek Rodriguez, and Wilson Holland from this team. Well done for a very excellent entry. You came up with a solution to challenge 3, water accessibility in a changing climate. The judges thought your entry was really solid. You have clearly sought to address an issue of social injustice and thought through the practical implications of your design and adapted it accordingly. Great work. And finally, drum roll, the winner of the 2022 World Engineering Day Hackathon is Team Wonderpets, an all-female team from Batangas State University in the Philippines. Congratulations. This team chose to address Challenge 3, water accessibility in a changing climate. The judges commented that this entry was very interesting with a potentially transformative technology. It seemed that your team had done a great deal of research, linked a logical solution to the problem that you were addressing, and considered wider implications. Congratulations to Gia Luwalhati, Nicole Elizabeth Tan, and Rena Jacqueline Boole from Team Wonderpets. You presented an excellent solution to your challenge, and you should be very proud of your achievement today. Thank you everyone for your support, and congratulations to everyone who participated in the hackathon. And thank you again to our judges for supporting this project and to our sponsors and partners. We couldn't have done it without you. Thank you.
Wonderful. Before we watch for the final time the winning entry from Wonderpets, let's hear a few more words from our finalist judges.
Looking at all the criteria that we used to judge them, like the innovative nature of the ideas, digital nature, the teamwork, I felt like all of this was actually a very good, very satisfying.
The first place is deserved by the Wonderpets, I think. The project is feasible and it has a lot of sustainable development properties, so I find it appropriate, this choice.
I would say congratulations to the team of the mobile rain harvesting system, and I would like to thank them for the work that was done. I think that the idea is really important, and the social impact of the project can be very big. It is really that the project is at its beginning and have to be performed, but I think that it has a good, let's say, scalability, and it can go too far. So I thank them, and I wish them the success in the future, and I congratulate them.
I think is interesting about the higher pack is that they'd taken it all the way through to implementation. They'd tested it, they'd shown how it had been successful in improving, the the success rate of tree planting. I want to say huge congratulations to Charles and Joseph from Team HirePack. We really liked the innovative element of your design, to take a weed, an annoying waste product that's choking up the lakes and rivers across the world, from what I understand, and turn it into something useful, and also not just something useful, but something that can give back to the environment through replacing plastic bags, planting trees. It's a really, really great idea. Amazing to see that you've already had some success. So we want to wish you the best of luck with your future venture in this space. And thank you for taking part in the World Engineering Day Hackathon.
Hi, I'm RJ.
Hi, I'm Gia.
Hi, and I'm Nicole.
And we are Team Wonderfest.
We are very honored to have been selected as a finalist in the World Engineering Day Hackathon in 2022.
Please enjoy our entry about water remediation using metal organic frameworks derived from PET bottles. Our study aims to address SDG 6 and 12.
Maraming salamat po and mabuhay!
You've undoubtedly heard the term water crisis. Perhaps you have already heard that 2.4 billion people do not have access to basic sanitation facilities. First, 80% of the wastewater generated by human activities are disposed into the bodies of water with no pollution remediation.
Toxic pollutants from numerous sectors have made their way into many water sources today. We need potable water to drink and to bathe, as well as to irrigate our lands and feed our pets and livestock. SDG 6 is more important than ever for humanity's survival, as water is to life and it affects us in a variety of ways.
Despite the fact that water treatment technologies are used in industries, several of these have drawbacks. Among treatment methods, adsorption is found to be most effective due to its low cost, simple, and efficient design.
However, conventional adsorbents have drawbacks that restrict their applications on a large scale. To address the limits of conventional adsorbents, we propose the use of metal organic frameworks, or MOFs, a novel material explored for its potential in various environmental applications.
We aim to use MOFs for the removal of a range of pollutants from wastewater to contribute to SDG 6. MOFs has what we call a breathing ability, which allows them to host guest molecules and push them out once external stimuli is applied.
This ability allows it to remove a large amount of pollutants and to be regenerated and reused, making it sustainable for water treatment. With its novelty, its raw materials and production process still need improvement. How do we aim to address this? By recycling plastic bottles.
With our knowledge in chemical engineering, we know that a certain component in plastic bottles can help us in producing MOFs in a less expensive and more environmental-friendly way. Over 3.8 million tons of plastic bottles are produced yearly, and only 7% of this are recycled, leaving the rest to pollute our waters and lands and affect wildlife. Repurposing them and giving them second life as protectors of our environment will contribute to responsible consumption and production, which is also another SDG we aim to address.
As a chemical engineering students, we developed a novel approach in the production of MOF adsorbents in a way that reduces costs, eliminates toxic reagents, and minimizes energy requirements. MOFs are composed of metal ions and organic linkers. To reduce cost, we use PET bottles as the source of our organic linker called TPA. We applied green method in extracting TPA from PET bottles through microwave depolymerization. TPA is non-dissolvable in water, requiring the process to use toxic organic solvents and extreme conditions to form MOFs.
Applying our engineering and chemistry knowledge, we converted TPA so that it readily dissolves in water.
This method enabled us to prepare MOF using just water as solvent and ambient conditions as opposed to conventional methods.
We successfully produced MOF in this novel approach and use it in removing dyes from water through adsorption. Aside from dyes, MOFs can also be used for the removal of pollutants like heavy metals and organic contaminants. Using our knowledge and separation principles from chemical engineering, we further improved the adsorption process using modeling, analysis, and optimization with the help of tools like Design Expert and Origin.
The MOFs we produce cost a lot less than commercially available ones. 1 gram costs us only about $4 to make compared to $67 available MOF in the market. The total estimated expenses in this project is only $500. We aim to get funding from partnerships with different universities and government institutions. We would want to further collaborate with industries in the nations in order to pilot test our technology in an operational wastewater treatment plant. State institutions may also be involved to safeguard the program's long-term viability by providing support for policy formulations for water pollution prevention.
There's a lot to learn about MOFs. Aside from PET bottles, other PET-containing waste may be investigated and metal scraps may be utilized as a metal precursor for MOF synthesis, which will be a part of a greater research that will be completed in a year or two. We researchers want to work with several organizations to investigate MOF as a 3D material. 3D printing offers another level to MOF manufacturing in terms of customizability, speed, and reusability in large-scale treatment.
Our team, Wonderfest, hailing from different cities of Batangas Province, Philippines, came and worked together in crafting our solution on water remediation using MOFs derived from PET bottles. Targeting both SDG 6 and 12, our solution aims to merge waste valorization and value adding with the challenge of clean water and sanitation. Through waste recycling, we aim to build back wiser. And through water remediation using MOFs, we aim to engineer a better future.
Thank you, and that was a wonderful video, and I'm sure that this team is going to take this project further.